So these kind of problems, I always start with solving my equation for theta when r is 0, just to see when you ended up at the origin. They're not x-intercepts. People usually call them the x-intercepts, but that's not the regular xy coordinate plane, so I guess I wouldn't call them the x-intercepts. So first of all, solve for r, and you get plus or minus the square root of 10 cosine 2 theta. Now if you set that equals to 0, you get cosine 2 theta equals 0. That happens. Cosine of what equals 0? Pi over 2 or 3 pi over 2. Therefore, the first angle is pi over 4, and the second option you have 3 pi over 4. We expect you to know what it looks like, and we talked about it. Well, I guess, Michael, you were not there on Friday, but the sine graph r squared looks like, like this. You get the two petals, but the cosine one is supposed to look like that. So, but let's say you don't remember and you want to actually sketch quickly. So start at 0, the 0 degrees. So here you are, right here. So when theta is 0, plug it in, where you get cosine of 0 is 1, and 1 times 10, 10. So take the square root, so you get square root of 10. So you do start somewhere here. And then we're going this way. Let's say pi over 4. You know what? You can take a better angle easier. So let's say before pi over 4. Let's say pi over 6. So this is your pi over 6. But let's see how long your r segment is. So plug it in. 2 times pi over 6 is pi over 3. I'm using this equation. Cosine of pi over 3 is 1/2. 1/2 times 10 is 5. And then you get the square root of 5. So you're on this ray, but the square root of 5, r, the length of r is square root of 5, so you're somewhere here approximately. So you're going this way. And then when you choose pi over 4, you end up with 0. We already figured this out before. So pi over 4, so this is your pi over 4 angle, but the r, the length of r, is 0. So you're right here. So basically you're going this way. And then you can continue and to make a little table, and you will see that nothing is going to happen on this side in this quadrant, but you're going to have another piece below the x-axis. Actually, I'm sorry, I meant when I said nothing happens in the second quadrant. Actually, you are going to get another petal on the other side. So, I mean, I can show you, Michael, later when I see you tomorrow how to graph by hand. But right now, so this is what it looks like. Now, I noticed what I can do, this is a perfect, perfect symmetry here. So you have this piece matches that piece. Now, if you find the area of this little piece, you can multiply it by the result by 4 to get the total area. Now the question is, what are the boundaries of your integral? The boundaries would be, you started here at 0, so you're going 0 and you're going this way. And when did we get another 0? When theta was pi over 4. So your boundaries are, you're between 0 and pi over 4. But then you're going to multiply your result by 4, don't forget. Well, the formula is, in order to find the area, you do 1/2 times integral, and then r square, r squared d theta. But r squared, we already have the equation up there, so it's 1/2 times 10 cosine 2 theta. And then you integrate this, and then don't forget to, you know what, you can just multiply by 4 now, right here. So this way you get 2. Actually 20, because if you take this 10 and pull it out, you get 20. And then you can integrate this easily, and you will get your answer, which is, I think the answer is A. I believe so.